we're asked to rewrite this equation into brackets, basically. So let's try and factorize it as best we can. It's not going to perfectly factorize because there's going to be a 9 that ends up going on the right-hand side. But to get uv, we're going to have a double bracket with a u here and a v here. So that term is sorted. And then if I put plus 3 in the right-hand bracket, that will guarantee me plus 3u when I multiply across. And then a minus 3 here will give me minus 3v. But I'm left with an extra term. I've got a minus 9 in there, so I need to add 9 to make up for it. I'm still minusing 18, and that is going to equal 0. So I'll get minus 9. If I add 9 to both sides, I get a double bracket equal to 9 as required. You can see that A is equal to 3 and B is equal to 3. In the next part, it says, hence, find all integer solutions to this equation. So we're going to go straight into this factorized form. Now, when you solve a normal quadratic equation, like x plus 2 times x minus 5 equal to 0, you might just basically go straight to minus 2 and 5, but it's because minus 2 is what makes this 0, and 5 is what makes this 0. You consider each bracket equaling 0 in turn. We can't do that here because there's a 9, but we can do something similar because we're only interested in integer solutions. There's actually an infinite number of solutions, so this could be 4.5 and this could be 2, for example, but for integers, there's just the factors of 9, essentially. So we could have u minus 3 equaling 9, and then b plus 3 would equal 1. Or we could swap them round. Or we could go with 3 times 3. But that's actually not it, not the only answers, because you could get negatives. They're quite easy to forget. So minus 9 and minus 1 would also work. There's nothing, they're integers, remember, there's nothing saying they can't be negative. And remember, we haven't actually found u and v yet. We'll deal with that in a second. So minus 1, minus 9, minus 3, minus 3. That's it. Okay, so just got to work back now to u and v. So I'm going to take this column and add 3 to every value. 12, 4, 6, minus 6, 2, and 0. Just do this really carefully. And then minus 3 from each of these values to give me v, minus 2, 6, 0, minus 4, minus 12, minus 6. And you don't need to write them out again. It's pretty clear that how they pair up. Those are our solutions. We're left with part C, to find all integer solutions to this equation. So it seems more complicated because we've got squareds going on. Now, one approach to this would be to try and get it into brackets in terms of x and y, like nice bits of x and y straight away, but you're going to end up with difficulties because as soon as you sort of put an x there and an x there, then and y's in there, you're going to get crossover terms of x, y. If you try and go with x squared and say y, you're going to get an x squared, y squared term. So there has to be a different approach. And what I noticed, whenever you see a difference of two squares, it's worth just going with that and seeing what happens. X plus y, x minus y, because this kind of removes, I mean, it hasn't removed the quadratic as such, it's just sort of disguising it. And I thought, what if okay, this is leading on from part B. What if I, for example, let that equal u and that equal b? So what would happen with that? We'd get u equals x plus y, v equals x minus y. If I add them together, I'm going to get 2x is equal to u plus v. So x is u plus v over 2. And if I minus them in a similar sort of way, I'll get 2y is u minus v, and then divide by 2, u minus v over 2. Because what happens then is that this equation is going to become u v, which is looking recognizable now, plus 6 times u minus v over 2 minus 18 equals 0. The 6 and the 2 cancel, leaving us 3, and we're left with uv plus 3u minus 3v minus 18 equals 0. This is the exact equation from part B. And we've already found those solutions. So if we go back and grab them, I've got u and v. Now I can construct additional columns for x, which is u plus v over 2, and y, which is u minus v over 2. So add them and divide by 2. That will be 10 over 2, 5. Subtract them. That will be 14 over 2, 7. And just carry on like that. Minus 10 over 2 minus 5, minus 2, that'd be minus 1. Minus 10 over 2 minus 5 again, then 7. Minus 3, and 0, that'd be 3. Probably doesn't hurt to just try one out and see if it does. So if we just pick one, let's go with 3 and 3. That's not too bad. Then we get 9 minus 9 plus 18 minus 18 equals 0. We can see it checks out. If you had enough time, you could check them all, but the only issue would be if I've slightly made a little mistake when I'm adding or subtracting them. So actually, look, that's not easy to spot to do that, but that once you realize the path, it's actually a very quick question. Well done.